Okay, so today we're going to talk about theoretical probability. Yesterday was experimental probability, okay, where we conducted an experiment and found the probability. Today we're going to talk about theoretical, okay. So theoretical probability is the number of ways an event can occur over the total number of likely outcomes. Okay, so yesterday we talked about flipping a coin. Okay, when I flip a coin, how many possible outcomes are there? 2, right? What are the possible outcomes when I flip a coin? Heads or tails? Okay, so when I talk about the number of ways the event can occur, I don't like seeing myself constantly. There. Okay. The number of ways an event can occur. If I say the probability of heads, how many ways can heads occur on a coin? Just one, right? There's only one head on a coin. So 1 out of the total number of outcomes, it's either heads or tails. So 1 out of 2. So theoretically, the probability of getting heads is 50%. Half of the time I should get heads. Is that the same as experimental probability? If I flip the coin 4 times, how many times should I get heads? Based on the theoretical probability, I should get heads twice. Right? Is that what's going to happen? Maybe. We'll try. I got tails. I got heads. That's 1 out of 2. Tails. So that means this one has to be heads. Tails. Okay, so my experimental probability was very different than my theoretical probability. Okay, theoretically I'm supposed to get heads half the time. Experimentally, what actually happened is I got it 1/4 of the time. Okay, tails never fails though, right? You guys have heard that saying. I definitely, over the yesterday and today, have flipped tails way more than heads. Okay, a point, number, cue, or other object is called fair if all the outcomes are equally likely. Okay, when I look at a coin, it's fair because it has heads and tails. If I have a number cube or a dice, right, it's fair because every side has a different number. And it's not weighted to roll on one side. So when you go to, like, if somebody on the street, like, if you've ever been in Vegas or something where they have all those street people doing tricks and trying to make you bet money, they probably have a die that's not fair. It's weighted on one side, so it's more likely to land on a different side. Okay, and that's how they can kind of get money from you. Okay? You think it's fair, but it's not. So, we are going to look at this. Calculate the theoretical probability that if I spin this spinner, what's the probability of getting a 4? How many spaces in the spinner are there? Go ahead.
So wouldn't it be 1 out of 5?
Yeah, 1 out of 5, right? Is this a fair spinner? Does every choice have an equal likelihood of getting it?
Yeah. Yeah.
So the probability of getting a 4 is 1 out of 5. We again want to write that as a percent. So what percent is that? 20%. Does that mean 1 out of every 5 spins I'm going to spin a 4? Probably not. Okay. How about this one? Spinning an even number. How many even numbers are there? Brooklyn? 2. The 2 is an even number and the 4 is an even number. So I have a 2 out of 5 chance of getting an even number. What percent is that? 40%. So I have a 40% chance of spinning an even number. Okay, how about the probability of getting a 1? Caleb.
1 out of 5.
1 out of 5. So again, that's 20%. There's only 1 1 out of the 5 spaces. Okay, how about an odd number? Probability of an odd. Savannah. 3 out of 5. And what percent is that? Go ahead, Pam. 60%. Okay, questions there? Does that kind of make sense? So if I said I'm going to roll a cube, I'm going to roll this die. What's the probability I would roll a 5? If I'm going to roll this number cube, the probability of rolling a 5 is what? Is 1 out of 6. Okay, which would be 16.7%. Okay. All right, flip the page. Okay, the next page is kind of a blank one, right? The next slide is blank. Okay, the next thing we're going to talk about is rolling 2 number cubes. And if I were to roll 2 cubes, we need to think about all the possibilities that could happen. Okay, if I just roll 1, what are my options? 1, 2, 3, 4, 5, and 6, right? But if I roll 2 number cubes, I have a lot more options. Okay, if I roll them both, I can roll a 2 and a 3. This time I got a 2 and a 4. A 1 and a 2. Oops. And where did it go? Thank you. And I can't hang on to either one. Okay, so lots of different options. So let's start listing the different options, but let's list them in a way that we won't forget any of them. Okay, so I'm going to start with, I could roll a 1 and a 1. Everybody agree with that? Okay. I'm going to make a column. I could roll a 1 and a 2. The first die could be a 1. The second die could be a 3. 1 and a 4. 1 and a 5. 1 and a 6. Everybody agree with that? So what would the next column look like? Caleb.
2 out of 1.
2 and a 1. That's what I'm going to start with. Okay, so I could roll a 2 and a 1, and then a 2 and a 2, 2 and a 3, 2, 4, 2, 5, 2, 6. Okay, then we could roll a 3 and a 1, 3 and a 2, 3 and a 3, 3, 4, 3, 5, 3, 6. So far, so good? Okay. Keep going. We could have a 4 and a 1, 4 and a 2, 4 and a 3, 4, 4, 4, 5, and 4, 6. We got 2 more columns to go. 5 and a 1, 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6. And then finally we could have 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. How many possible outcomes are there of rolling 2 die? When it was just 1, there was only 6 possibilities. When I roll 2, how many possibilities are there? Right? 36. Good. There are 36 possible outcomes. So if I said, what's the probability of rolling 2 ones? How many of those outcomes are 2 ones? The probability of 2 ones would be what? Caleb.
Oh, 1
1 out
out of 36.
of 36. And now remember, we're still going to change that into a percent. So 1 divided by 36 is 2.8%. Is that a very good chance of rolling 2 ones? No, not really. Okay, so with that, okay, I just made a copy of that, but that's what that would look like. Okay, that's what we just wrote down. So let's look at this. The probability that the total shown on the 2 dice would equal 1. What's the probability that the total shown on the 2 dice would equal 1? What do you think? Savannah? 0? Yeah. Would you agree with that? 0 out of the 36 spaces, or outcomes, so it would be a 0% chance that the total shown will equal 1. That can't happen. Okay, the probability that the total shown is greater than 10. Okay, I know these are pretty little, but let's start over here. 6 plus 6, is that greater than 10? Okay, so there's 1. How about 5 plus 6? How about 4 plus 6? Why not? Why can't I count that one? Caleb.
Because that's 10 and has to be greater.
Good. That's 10 and it has to be greater than 10. So I can't go, okay, 6 plus 5? I can use that. How about 5 plus 5? No. 6 plus 4? No. So there are only 3 of them that the total is greater than 10. So 3 out of 36. And as a percent, that's 8.3%. Again, not a real good probability. Okay, the probability of rolling 2 even numbers. Okay, for me it's easiest to go through and circle these. They both need to be even numbers. What are even numbers? 2, 4, 6, 8. 2, 4, 6 in this case. And both dice have to have an even number. So can I choose any from this column? No. Here they're both even. Both even, both even. These all have a 3 and that's an odd, so I can't choose from there. Here they're both even, both even, both even. These all have a 5. How many are both even? 9 out of 36. And so 9 divided by 36 is 25%. Okay. What if I said, what's the probability of getting doubles? What's the probability of getting doubles? Meaning both numbers are the same. Easy. 6 out of 36? 6 out of 36. There's 1, 2, 3, 4, 5, 6. So 6 out of 36, what percent is that? Go ahead, Caleb.
16.7%.
16.7%. Okay, questions there? Okay, we're going to skip those last 3 slides. We're not going to do them. But we're going to play skunk again, too. That's, yay, right?
Yeah.
That's
Yeah.
You all have better luck this side of the room, one's better luck today. Okay, but we're playing with 2 dice today only. Okay. So yesterday we played with 2 dice and then 1 dice. We're gonna do 2 dice only.
Que depende con el clima.
Okay, so take a recording sheet and pass it back. Alright, so do you remember the rules? Okay, so 5 rounds. If I roll a 1 on either die, you lose all your points for that round. If I roll snake eyes, that's 2 1s, you lose all your points that you've collected so far. Okay? Does that make sense? Alright, everybody stand up. Okay, ready? Here's the first roll. We got a 2 and a 3. So far you've got 5 points. Okay? Next, nobody wants to sit yet? No? Okay. Oh, somebody should have sat. 1 and a 2, the round is over. Nobody has any points.
She's rigged it.
I didn't rig it. You guys think I sound suspicious? Like, I know what's gonna happen. No. If I had that ability, I'd go buy some Powerball tickets. Like, for real. Alright, everybody up. Round 2. Okay, nobody has any points yet, so. Okay, 2 and a 3 again. Anybody want to sit? Okay, now if I roll a 1, you guys can't blame me. I gave you the option to sit.
Nobody's gonna.
Nobody's gonna sit? Okay, here we go.
Can't be.
6 and a 3. So 9 plus 5, so far we got 14 points. We're at 14. Anybody want to sit? Okay, we've got some people sitting. Anybody else want to sit? Okay. Alright, here we go.
Okay. Yeah.
2 and a 2. So we're up to 18 points. Alright, some more people sat. Lily, you're taking your chances after yesterday. You think maybe you would have learned. Okay, here we go. So 5 and a 4. So 9 points, so we're up to 27.
I'm gonna sit down.
You got 27 points so far. You gonna risk it? Oh, Tyler's out. Okay, Kason, you're gonna keep going?
Yep.
You're gonna keep going? Okay. Oh my god. 2 and a 3. So we're up to 32 points. Oh, Lily's gonna sit. She didn't learn. Okay, so we're gonna go again. Okay, here we go. Oh, 6 and a 6.
That's my shot. That's my
12 points, so we're up to 44.
My kind of sit.
Oh, he's done. Okay, so that round is done. So add up your points for that round, depending on where you went out. Okay, and then stand back up.
Watch us get a 1 this time. Watch us get a 1. I always try to get a 1.
Okay, ready? Here we go. We've got a 5 and a 6. So we've got 11. Anybody want to sit?
No.
Now, you guys got to remember that now, if I roll 2 1s, you lose everything. Gosh.
Well, a little bit 45 points.
Nobody's going to sit. Don't be mad if I roll 2 1s. Okay, 2 and a 4. So 6 more points. So we're up to 17. Anybody want to sit? No? Oh, Cassidy's out. Caleb, are you going to sit? No? Okay. Oh, nice choice. So Cassidy keeps her 17 points. The rest of you, 0. Okay. Now you got to decide. Do you want to stand up at all?
Yes.
If I roll 2 1, you're out.
I don't care. We play.
Okay. Ready? You're all a little nervous.
Go.
Okay, 2 and a 6. So you got 8. Everybody want to sit? Nobody wants to sit yet. Okay.
We got a 1.
Oh, 5 and a 4. So 17 points. You want to sit yet? Some of you are. Oh, one more you say. Okay. Here we go. I told you to sit. Okay, so
we're blaming ourselves.
some of you have 0. Some of you were able to keep your 17 points that round. Okay. All right, last round. Stand back up.
You don't want to go.
Maybe. Okay, ready?
What?
You all got 0. Okay, so add up your total points.
Matthew.
Okay. Raise your hand if you have more than 30 points. More than 30.
More than what?
More than 30. More than 40. More than 50. No. Okay. More than 45. What do you have? 48. Anybody have more than 48? What did you have? 44. Close. So first place, second place. Okay, now there's some questions on the bottom. We're going to answer these questions. Okay, based on the game, based on what happened in the game, are we finding experimental probability or theoretical probability? Experimental, right? Based on what happened in the game, we're looking at experimental probability. So the first one says the probability of losing all your points for one round. How many times did you lose all your points in one round? Or how many times did that occur? 1. This round I never had to stop. 2, 3, 4. So 4 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 rolls. So 4 out of 15. 4 divided by 15 is 26.7%. 26.7%. Okay? I need to write that down because we're going to compare that. Probability of losing all your points. Did that ever happen?
No.
No. So 0 out of 15 is 0%. The probability of getting more than 10 points. How many times did that happen? That you were
Are we doing like our own or?
No, so based on what happened overall.
Ready?
So more than 10 points.
Good, Deb.
The 6 and 6, right? And so the probability of greater than 10 only happens 1 out of 15 tries. So 1 divided by 15 is 6.7%. Okay, that's not very good, is it? Now, let's talk about theoretical probability. In theory, okay, you might have to go back to your notes and look at your table. Okay? In theory, the probability of losing all your points for one round. How many possible outcomes are there when I roll 2 die? When I roll a pair of dice, how many possible outcomes are there? 36. Okay, I'm going to go back to this. Right here. There were 36 possible outcomes, right? The probability of losing all your points in a round, how many times could that occur? Caleb. 11. Do you guys agree? What causes you to lose all your points in just one round? Not snake eyes. The ones, right? So 1, 2, 3, 4, 5. Would I count that one? That's all your points overall, right? So 1, 2, 3, 4, 5. So 10 out of 36.
Oh yeah.
Agreed with that? 10 out of 36. That is 27.8%. How does that compare to the experimental probability? What was our experimental probability of losing all your points in one round? What did we have? We had 26.7%, right? Is it pretty close? Yeah, it's a lot closer than what I would think it would be. Okay, it was very close to what we had in the experimental. Okay, probability of losing all your points. What causes you to lose all your points? Snake eyes. So right here, this would make us lose all of our points. That's just 1 out of 36. 1 divided by 36, 2.8.
Oh yeah.
Be careful rounding. What was our experimental probability of that happening? 0. Kind of close yet though, right? It's difficult to get snake eyes. If you're waiting on snake eyes, it's going to take a while. Okay? The last one, the probability of getting more than 10 points. More than 10 are these right here. I would be getting 11 or 12. So 3 out of 36. Which is 8.3%. How did our experimental probability compare to that? It was close. It was a little bit less, right? We only had 6.7%. So we probably should have rolled one more that was more than 10. And it would have been closer to the theoretical. The point being, the more times you roll the die, the closer and closer you should get to the theoretical probability. If we were to go back and keep track of what we rolled for another 15 rolls, it should get closer. Okay, experimental probability and theoretical probability should be close. Questions there? Does that make sense to everybody? Okay. Then, I'm going to give you the rest of the time to work on your homework. Okay, so you guys can go